Let's begin with what might be the single most overlooked yet powerful tool for enhancing focus and learning: morning sunlight exposure. This isn't about some abstract wellness habit. It's about anchoring your brain and body to the natural rhythm that governs everything from alertness to hormone release to the timing of neuroplasticity. Here's how it works. In your eyes, specifically behind the retina, are specialized cells known as intrinsically photosensitive retinal ganglion cells. These aren't involved in vision, but they detect light, particularly the blue light that's abundant in the early part of the day. When these cells are stimulated by sunlight, they send a direct signal to a part of the brain called the suprachiasmatic nucleus, or SCN. This region is your body's master circadian clock. It controls the timing of virtually every biological function, from your sleep-wake cycle to hormone production, core body temperature, and critically, mental alertness. When you get bright sunlight in your eyes within 30 to 60 minutes after waking, you're sending a clear signal to the SCN. The day has started. In response, the brain increases levels of cortisol. Now, most people associate cortisol with stress, and yes, chronic elevations are problematic, but in the morning, a sharp rise in cortisol is not only normal, it's essential. This early cortisol pulse acts as a wake-up signal to your entire system. It increases blood sugar slightly, enhances alertness, boosts your immune readiness, and primes your brain for learning. What's critical is that this cortisol spike happens early. If you miss that window and stay indoors under dim light, your cortisol release gets mistimed. That delay disrupts your focus, energy levels, and even your ability to fall asleep at night. You're essentially running your brain and body out of sync with your environment, which leads to brain fog, poor memory consolidation, and inconsistent mood. Moreover, early morning light exposure sets the timer for when melatonin, a hormone that promotes sleep, will begin to rise later that evening. This light-driven mechanism is a 24-hour loop. Proper morning light locks in better sleep at night, and better sleep means stronger learning, memory consolidation, and attention span the next day. The cycle builds on itself. And here's the thing. Artificial indoor lighting is nowhere near strong enough to trigger these pathways effectively. You need natural light. Even on a cloudy morning, going outside for just 5 to 10 minutes is enough. On a clear day, 2 to 3 minutes may do it. No sunglasses, no windows between you and the light. Just step outside and let your eyes do what they've evolved to do. This is not a supplement. It's not a stimulant. It's a non-negotiable part of how your nervous system calibrates attention and learning potential. If you want to sharpen your focus, increase your ability to absorb new information, and build a brain that functions at its peak, start with the sun. Every day. First thing. It's foundational biology. One of the most powerful yet underutilized principles of focus and learning lies in understanding how your brain naturally cycles through periods of alertness and fatigue throughout the day. These are called ultradian cycles. Specifically, your brain operates in roughly 90-minute blocks where attention, energy, and cognitive performance rise, peak, and then decline. If you know how to work with this rhythm instead of against it, you can unlock a far greater level of focus, learning, and productivity without burning out. Here's what's actually happening. Your brain and body shift through alternating states of high alertness and physiological recovery. These cycles are driven by the interplay of neurotransmitters like acetylcholine, norepinephrine, and dopamine, which regulate your ability to sustain attention and engage deeply in complex tasks. In the first part of the 90-minute cycle, these chemicals are elevated, sharpening your focus, increasing your working memory, and enhancing your pattern recognition. This is when you want to do the hard stuff: deep reading, writing, problem solving, creative work, or studying something challenging. But around the 75 to 90-minute mark, you'll notice your focus starts to drop. Maybe you begin to fidget, reach for your phone, reread the same sentence, or your mind just starts to drift. That's not failure. That's biology. Your brain is signaling the end of one ultradian cycle. At this point, pushing through with caffeine or willpower might get you a bit further, but the cognitive return drops off steeply. What you need isn't more effort, it's recovery. So the key is to work with these cycles. Structure your day into 90-minute focus blocks. Eliminate distractions during that time. No email, no phone, no multitasking. Protect it like you would a meeting with someone important. Because it's a meeting with your highest functioning brain state. Then, when the cycle ends, step away, take 10 to 20 minutes to reset your system, go for a short walk, do breath work, hydrate, or just let your mind wander without stimulation. This recovery phase is not wasted time. It's what allows the next cycle to start strong. What's also fascinating is that during these recovery periods, the brain goes into what's called default mode. This is when the mind processes and integrates information unconsciously. So that problem you couldn't solve during the deep work phase, the solution may surface after the break without effort. It's not magic, it's neurobiology at work. Over the course of a day, most people can get 2 or 3 of these deep 90-minute cycles, sometimes 4. You don't need to be in hyper-focus mode all day. That's not sustainable, and more importantly, it's not how the brain is designed to function. The goal is to align with the brain's natural oscillations, not override them. By working in sync with your ultradian rhythm, you reduce mental fatigue, improve learning retention, and get significantly more meaningful work done in less time. It's not about grinding harder. It's about timing your effort when your brain is wired to deliver its best. One of the fastest ways to shift your state of focus or calm is through your visual system. Not by what you look at, but how you look at it. Most people think of vision as just a tool for seeing the world, but in reality, your visual system is deeply tied to your brain's alertness, arousal levels, and even your ability to concentrate or relax. The way you direct your gaze sends powerful signals to your nervous system that adjust your internal state in real time. Here's how it works. Your eyes are not just cameras. They are actually part of your brain. They're the only part of the central nervous system that sits outside the skull. And the movements of your eyes directly influence neural circuits related to attention and alertness. When you narrow your field of vision, meaning you focus intently on a single point, like the words on a page or the center of your screen, you activate a part of the brainstem called the locus coeruleus. This area is a major source of norepinephrine, a neurochemical that ramps up alertness and sharpens cognitive focus. This narrow tunnel-like vision is what your body naturally uses in moments of urgency or high concentration. Think of an athlete before a sprint or a predator locked onto its target. That visual focus isn't just symbolic. It triggers a physiological cascade that increases heart rate, heightens awareness, and boosts readiness for action. When you intentionally focus your gaze this way, even for just a few seconds, you're flipping the switch on your brain's attentional systems. On the flip side, when you deliberately widen your gaze, what's called panoramic vision, you activate different neural pathways that decrease stress and induce calm. This is the kind of vision you use when you're taking in a landscape or watching a sunset. You're not focusing on any one thing. Instead, your visual field broadens to take in everything. This wide field viewing reduces activity in the amygdala, the brain's threat detection center, and increases parasympathetic nervous system tone. That's the branch of your nervous system responsible for slowing heart rate, lowering blood pressure, and promoting relaxation. So what does this mean in practical terms? If you're feeling overstimulated, distracted, or anxious, deliberately widen your gaze can bring your system down. Step away from your screen, Look out a window or just soften your eyes and take in the full room without focusing on anything in particular. Within seconds, you'll feel your breathing slow and your mind settle. If, on the other hand, you're trying to enter a deep work state or prepare for a cognitively demanding task, briefly narrowing your gaze, just 10 to 30 seconds of directed visual focus can help lock your brain into a mode of heightened concentration. The takeaway is this: your eyes are a steering wheel for your mind. You can use them to dial your focus up or down depending on what the moment requires. And the best part? This is immediate. No supplements, no gear, just conscious control of how you use your vision to modulate your internal state. When it comes to quickly shifting your mental state, especially when you're overwhelmed, anxious, or cognitively foggy, there's a powerful tool built right into your nervous system. It's called the physiological sigh. This is not breath work in the spiritual or meditative sense. This is a scientifically validated, hardwired mechanism your body uses to reset your internal state. And it works almost instantly. Here's what a physiological sigh looks like. It's 2 quick inhales through the nose, 1 full, followed immediately by a shorter second inhale, and then a long, slow exhale through the mouth. So it goes inhale, top off inhale, slow exhale. That's it. 1 to 3 rounds of that, and you can shift from a state of stress or distraction into clarity and calm within seconds. To understand why it works, you need to understand how breathing interacts with your brain and your body's arousal systems. When you're stressed or anxious, your breathing becomes shallow and rapid. This leads to a buildup of carbon dioxide in the bloodstream, which in turn makes your brainstem signal to the rest of your body that something's wrong. Heart rate increases, muscles tighten, and cognitive control begins to erode. A physiological sigh reverses that. The first deep inhale expands the lungs and partially reinflates the alveoli, the tiny sacs in the lungs that facilitate oxygen-carbon dioxide exchange. The second, shorter inhale helps open up any collapsed alveoli that didn't fully inflate during the first breath. Then the long exhale dumps carbon dioxide rapidly and fully activates the parasympathetic nervous system, which governs relaxation and recovery. The reason this technique is so effective is because it's already built into your biology. In fact, you perform physiological sighs naturally, especially during sleep, deep emotion, or after crying. They're your body's emergency brake for stress, designed to restore homeostasis quickly. What's remarkable is that you can voluntarily trigger this system. You don't need to meditate for 20 minutes, lie down, or change your environment. You can be sitting at your desk, standing in line, or preparing for an intense cognitive task and reset your entire system with 2 controlled inhales and 1 exhale. From a cognitive perspective, the reduction in stress via this method increases dopamine tone and enhances prefrontal cortex function, the part of your brain responsible for focus, decision-making, and learning. That's why the physiological sigh isn't just about feeling better, it's about functioning better. You restore your ability to think clearly and stay present. So the next time you feel your mind racing, you're unfocused, or your body is in a state of agitation, don't just power through it. Use this tool, 1 to 3 physiological sighs, and you'll feel a marked shift in both body and brain. It's the fastest, most efficient way to reset your system, and it's built into your nervous system waiting to be used. When it comes to learning something deeply and retaining it long term, repetition is essential, but not just any repetition. The timing of that repetition is what makes the difference between fleeting familiarity and lasting mastery. This is where the principle of spaced learning comes in. It's not only more effective than cramming, it's how your brain actually wants to learn. Here's what's happening at the neural level. Every time you expose yourself to a piece of information, whether it's a concept, a skill, or even a movement pattern, you activate a network of neurons. These neurons communicate across synapses, and with each meaningful repetition, those synaptic connections strengthen. But here's the key. The connections don't strengthen most during the act of repetition itself. They strengthen during the rest period that follows. That's when consolidation happens. That's when the brain decides this information is important enough to keep. Cramming, repeating something over and over in one long session can feel productive in the short term. You might even recall the material the next day, but you're not really building durable neural pathways. You're just flooding your short-term memory buffer, which is fragile and quickly wiped clean. The brain doesn't interpret cramming as meaningful because there's no signal that the information is worth preserving long-term. Spacing out your repetitions does the opposite. When you encounter the material, walk away, then revisit it hours or days later, you're creating what neuroscientists call retrieval difficulty. That effort to recall, when it's just a little bit hard, is exactly what drives neuroplasticity. The brain flags that information as valuable because it had to work for it. You're not just reviewing. For example, if you're learning a new concept or studying something important, review it once in the morning, briefly revisit it later in the afternoon, and again the next day. Keep the sessions short, 5 to 10 minutes is enough. What matters is not the volume of review, but the timing and spacing of it. Over time, you can extend the intervals between reviews. This is called expanding retrieval, and it's one of the most robust methods for building long-term memory. Sleep plays a crucial role here too. During sleep, especially deep and REM sleep, the brain replays and consolidates what you learned during the day. Spaced learning syncs perfectly with this process. When you revisit material across days, each sleep cycle strengthens the neural traces even further. You're not just learning. So the next time you're tempted to grind through hours of uninterrupted studying, ask yourself, do you want to feel like you're learning or actually learn? Use short-spaced sessions. Make the recall just a little effortful, and trust that the discomfort of forgetting and retrieving is not a problem. It's the signal that learning is happening at the deepest level. Neuroplasticity, the brain's ability to change in response to experience, isn't just something that happens randomly. It can be deliberately targeted and optimized with specific behavioral protocols. And when it comes to focus and learning, understanding how to tap into these windows is the difference between shallow exposure and real, lasting change in your brain. First, let's define what neuroplasticity actually is. It's the process by which neurons form new connections or strengthen existing ones in response to experience, attention, and effort. It's how you learn new information, build skills, overcome bad habits, and reshape your mental and emotional patterns. But here's the catch. Neuroplasticity is state dependent. The brain doesn't change just because you're exposed to something new. It changes when it gets the right signals, and those signals come from your internal state. So what drives those plasticity-ready states? One major factor is epinephrine, also known as adrenaline. When you're highly alert, when your heart rate is slightly elevated, your visual field is narrowed, and you're intensely focused, your brain flags what's happening as important. That's the opening of the plasticity window. In that state, the brain is essentially saying, pay attention, this matters. If you pair that heightened focus with a learning experience, you increase the odds that the brain will wire that information into long-term memory. But neuroplasticity doesn't end there. The actual rewiring happens after the learning session, during deep rest, especially sleep. So here's the protocol. You need periods of high alert, high focus for learning, followed by periods of deliberate disengagement, calm, rest, or sleep for consolidation. That pairing is what makes the change stick. It's a two-phase process. Trigger plasticity with effort and focus, then seal it with recovery. There's more. You can actually amplify these windows with something called error-based learning. When you're trying something new and making small correctable mistakes, you're operating at the edge of your capability, right where neuroplasticity is maximized. That's because your brain is getting real-time feedback. What's working, what's not, and where to adjust. The discomfort of making errors paired with effortful correction creates a potent signal to change the underlying circuitry. You can also prime your system with simple behavioral tools. For example, doing 1-3 minutes of intense physical movement like jumping jacks or a quick run in place before a focused work session raises your alertness and readiness. Pair that elevated state with 90 minutes of focused learning, then follow it with a walk, a nap, or ideally a good night's sleep. You've now created the conditions for meaningful, long-lasting brain change. The key point is this: neuroplasticity doesn't require you to rely on luck, genetics, or sheer repetition. It's a process that you can access deliberately through how you engage your body, your attention, and your rest. Use this wisely, and your ability to learn, adapt, and evolve isn't just improved, it becomes intentional. When it comes to boosting focus and accelerating learning, there's a tendency to reach immediately for tools like supplements, stimulants, or hacks. But the truth is, those things are secondary. The primary levers that shape your ability to concentrate and retain information are your environment and your behaviors. These are not just supportive elements. They are the foundation of cognitive performance. And unless you get those right, no pill, powder, or app is going to make a meaningful difference. Let's start with your environment. The brain is a prediction machine. It's constantly scanning your surroundings for signals of safety, urgency, novelty, or distraction. If you're trying to do deep work or learn something new in an environment filled with visual clutter, random noise, or constant digital interruptions, you are setting yourself up to fail. It's not a willpower issue. It's biology. Each notification, sound, or open browser tab hijacks your limited attentional resources and shatters your focus. So the first step is to curate your environment. Remove unnecessary stimuli. Set physical boundaries for your focus sessions. Turn off notifications, close redundant tabs, use noise-canceling tools if necessary. Your surroundings should signal one thing to your brain. It's time to focus. That clarity reduces cognitive friction and allows your brain to enter what's called a high acetylcholine and norepinephrine state, neurochemical conditions. But the environment is only half of the equation. Your behaviors, especially the ones you repeat daily, send even louder signals to your nervous system about when and how to engage. For example, consistent wake times, morning sunlight exposure, movement early in the day, and structured focus blocks are behavioral anchors. Each of them sets the tone for how your brain allocates energy and attention across the day. Here's where it gets powerful. These behaviors don't just make you feel better, they directly influence your brain's neurochemistry. Bright light in the morning increases cortisol at the correct time, movement boosts dopamine, and focus sessions that follow a ritualized routine trigger the prefrontal cortex to enter task mode. That's where learning happens. That's where you can hold and manipulate information, solve problems, and wire in new circuits. And none of that requires a supplement. That's not to say supplements don't have a place. They can be useful, but they only work if your behaviors and environment are already optimized. Taking a cognitive enhancer in a distracted, unstructured state is like pouring high-octane fuel into a car that hasn't had an oil change in years. It doesn't help. It might even backfire. The reality is your brain is highly responsive to simple, actionable inputs: light, movement, breath, visual focus, task structure, rest. These are your first tools, your most potent ones. They're free, immediate, and rooted in how your nervous system actually works. Master them, and you build the baseline for consistent, high-quality focus and learning. Everything else is just augmentation. So here's what it all comes down to. Your brain is not a black box. It's a highly trainable system, and the keys to unlocking better focus and faster learning are already within your reach. You don't need exotic supplements or complicated tech. You need to work with your biology using light, breath, movement, visual attention, structured work blocks, and recovery to guide your nervous system into states of deep concentration and lasting change. When you understand and apply these principles, exposing yourself to morning sunlight, aligning with 90-minute focus cycles, using your eyes to control alertness, employing physiological size to reset your state, spacing your repetitions to consolidate memory, triggering neuroplasticity with intensity and rest, and designing an environment that supports your goals, you're no longer hoping to focus, you're engineering it. Every day becomes an opportunity to practice and refine the skill of mental performance. Because that's exactly what it is, a skill. And once you take control of these levers, you gain the ability to shape your mind with precision and purpose.